Okay, so Unit 4 was modeling. If you take a second and read 23, they want to present this table as their complete report. Is this a good idea? I don't think that's a good idea. There's nothing but a table of data, so they should include what they did, an explanation, more data. Just giving 5 data points is not enough for a complete report. Okay, so that 2 and 4 match. Except there's a typo. This should be D of 2 and D of 4. So when you plug in 2, we get 80. That worked. And when you plug in 4, you get 20. That works. What are allowable values? Because D is a distance, we're going to say that D can be any, we're going to say positive real number, so greater than 0, because D is a distance. Okay, so which model should we use to get to 1.6 lux? If you use the table, you'd have to keep doing your experiment until you got to 1.6. So I don't think that's the best way because it could be tedious. We don't know if we're going to get to the exact 1.6 value. So table's not great. For the graph, you could go to 1.6, but that's really hard to read on this Y scale. So again, probably not the greatest way. So we took off table because that graph is not scaled to get an accurate value for 1.6. So using the formula, if we look back at what it was on the other page, we could plug 1.6 in and just solve. So I think that's the best way. It's a pretty straightforward equation. It's given to us. I would solve then for the distance, plugging in the 1.6. Okay, so for 34, we have to check both of her models. We have to check it for every piece of data up here, so all 4 numbers. So f of 1 is 1, so that means f of 2, the second term, is the term before plus 2 squared. And let's see, that's 5. Oop, that works. F of 3 is the term before plus 3 squared. That works. And then the fourth term is the term before plus 4 squared. And that works. So her recursive model, correct. Now let's check the explicit. So when you plug in 1, we get 1. When we plug in 2, we get 5. When you plug in 3, we get 14. So far it's working. And when you plug in 4, we get 30. So both models work. The key with this question is you have to test all 4 values. You can't just do 1 or 2. You have to do every single one of them. Okay, so for 25, so for A, this is like modeling an exponential, but because of the waves, I'm going to say it's also a sine or a cosine. It doesn't matter which one, I'll say sine. And then for B, this general shape is quadratic. And again, it's also a sine or cosine because of the waves. The function type for B, do not say parabola. Parabola is the shape of the graph. Quadratic is the function type. You have to be precise with your language. Okay, so for 26, what type of function do I think best models this data? If I look at it, oh, we got 0, 40, 80, 40, 0, 40. Kind of making this wave pattern. So I would say it's some kind of trigonometric sine or cosine because of the oscillating data that's repeating. He thinks this equation is a good model. Is he correct? Well, let's test some of his points. If we plug in 0, what do we get? Now you have to make sure you're in degree mode because of this. When you evaluate that in your calculator, you're going to get 40, which is not 0. So again, right there, that first point does not work. Now let's modify it. Well, if sine didn't work, maybe cosine will. And let's test some points. So if we plug in, what you could do is in your calculator to look at all the values, put this in Y1, and then look at your table of values, and then do they match this table of values? And it should. Okay, we're going to sketch these X and Y coordinates onto the coordinate grid. So if you'd like, I'm going to do this over here so I can see it. At time 0, we're at negative 4, 3. At time 1, we're at negative 3, 3. Negative 1, 0. 0, negative 1. So these are all the points I'm going to plot. All right, now I don't need that top part. So let's see, negative 4, 3. Negative 3. 3. And you have to go in order since the time from that parametric data matters. Oops, that's in the wrong spot. So connecting them with my segments. There is our graph.